Thanos is a professor of architectural engineering at Purdue University. Thank you. And for the past 6 years, he's also the president of Advanced Building Energy Consultants. He specializes in building energy modeling and simulation, lighting and shading controls, building design and operation, energy efficiency, and renewable energy systems for buildings. And Purdue University's project is focused on sustainable building systems, indoor environmental conditions, and human interaction with controls in order to develop better design guidelines and operational strategies for buildings. So here you go.
Thank you. All right. Thanks for being here. It's great for me to be here. Our project, the title of our project with Architecture for Humanity and Alcoa Foundation is called Integration of Humans into Building Design and Operation. And I started with this picture because it's a picture showing a poor indoor environment, a poorly designed indoor environment, mostly like the ones we're sitting over here right now. You see the diffusers on top of us that might be facing downwards, causing discomfort. Sometimes it's underlit or overlit, but even if you have a nice space, perimeter space, which is overlit, we must have problems that have to do with discomfort, glare, and overheating, and other things. So glare is one of the things we work with here. Disability glare, excessive amounts of daylight following your workspace, coming from windows or from light sources, how to fix problems like that. This is part of the project we're working on, and it has to do with perimeter spaces, facades, and daylighting primarily. So no matter what the conditions are outside, we could always design and configure our facade systems, indoor environment systems, to make a comfortable indoor environment. So it might be very well and sunny outside or cloudy outside, but no matter what it is, we really like to have a productive and comfortable indoor environment. So people found different solutions, different types of shading devices, operable windows, light shelves, overhangs, even adaptive facades that you will hear in a few minutes from another presenter. Motorized shades and blinds on the windows, they help towards that with manual override. All these systems help towards this goal, but there's still problems in designing and operating these systems. So the problem lies in the fact that this is a purely subjective issue. So people have different preferences in the comfort, in terms of visual comfort and thermal comfort. So in this project, we try to set a new set of design guidelines to accommodate everyone and make sure that we have better indoor environments. I'm not going to go into the equations, but there is an equation describing daylight glare that has two parts. One is the overall brightness, and the second part is the luminance of surfaces. And depending where you sit in the office, you might have an exposure to different luminances that affect your visual comfort and your field of view. So what we've done is we designed a variety of spaces, one of which is shown here. This is two experimental test offices placed side by side. And these are fully instrumented with reconfigurable facade systems, shading, lighting, and air conditioning systems. You can see some of those in the previous picture. And we do have a special camera. What it does, it takes pictures with a fisheye lens, like the ones here, and then converts that to luminance images, so we know how bright the surfaces are in reality. And then we process these images and we identify potential glare sources from windows or from lighting fixtures and so on. And then we monitor how shades or windows perform throughout the day and throughout the year. This is a motorized camera, so it takes pictures every few seconds. So we can see how the space performs, and then we extract our indices from these pictures in terms of daylight glare probability, for example. And that helps us identify problems and create a new set of design guidelines. And then we have special ways of printing those on paper or in presentations. So this is called a temporal graph, and every pixel there is a condition for a particular time in the year. So whenever you see a yellow color or a red color, that means there's a problem. We have more glare than what we need. So this is a simulation way of identifying the problems and then trying to fix those. One of our unique features are the living labs, which are on the third floor of our new facility, which is the Center for High Performance Buildings. Reconfigurable open plan office spaces, fully occupied, so we can change the facade systems, the lighting systems, the air conditioning, materials, etc. We have air-based systems and hydraulic systems, so underfloor and overhead air distribution, right? All kinds of flexible controls. And the purpose there is to study how people feel about changes in their environment and try to monitor environmental conditions and see how they match with occupant preferences. So these are some other pictures with the modular clouds inside, chill beams, and a full glazed facade on one side. We have a double skin facade, and this is how the space looks like, with about 20 students occupying each of these open plan office spaces. So we have been doing surveys and questionnaire, playing with different types of design inside, and the objective there is to have a portable weather measurement station that has this special camera on top of a computer and then some photometers. So we go around and we take pictures, we measure the conditions. At the same time, we ask people how they feel about the conditions in that space. And then we're trying to match the preferences with existing indices, which is what I've been trying to show here. So this is from real measurements in the living labs. Dissatisfaction of people versus what we right now know as a glare index. And as you can see, there's discrepancy. So our objective is to have another set of guidelines mapping human discomfort with design and operation of these spaces, including the comfort indices in the end. And then we can use these results and map out, for example, daylight autonomy or glare situations or different comfort variables for different locations in the US. So people have design guidelines for perimeter zones of primarily office spaces. So this is just the samples. We also have outreach activities, which is part of this grant. So we have brought schools in our labs and gave tours, and then we have a big conference organized every 2 years. You can see people of professional students and academics going around these living labs, and then we have dinners and speakers, a set of posters, so people go around for an hour looking at talks and seeing posters. We have a student design competition, which was held this July, so this is all the awardees, and actually the student working with me in this project was one of the awardees. It was very good to see that. And then, of course, we have schools involved with our research, so elementary schools and middle schools involved, so the kids learn about sustainable buildings and indoor environment, and the teachers are engaged in this. And this is a group of about 55 students participating in the living lab surveys. So we'd like to thank them very much for doing that and giving us precious results that we can use to design spaces in the end. And I think my time is over, right? Thank you.
Thank you, Thanos. That was wonderful. And good to know that our discomfort is quite high here at 82 Mercer. Thanks. That's why we need the scarf, right? So I think we're all ready to go. We want to get Susan up here, or Nina, I'm sorry, because she has a flight to catch, apparently. So we need to make sure she... Okay, so that she can share with us. So I'm going to reintroduce Nina. She's an adjunct instructor and candidate for a PhD in building performance and diagnostics at Carnegie Mellon University School of Architecture. She teaches courses in zero energy housing, LEED, and green design concepts. So thank you, Nina, for your patience, and here you go.
Stone Soup is a folk tale about the power of community to collectively make something wonderful. Our 2-year grant is a building renovation and citizen-driven redevelopment project in Hazelwood, a Pittsburgh neighborhood that has lost more than 60% of its population since the steel industry collapsed in the 1970s. Hazelwood is less than 4 miles from downtown Pittsburgh and just a stone's throw away from the city's largest redevelopment site, 178 cleared acres. This can seem somewhat overwhelming to Hazelwood residents, 25% of whom live below the poverty line and 50% are renters. Our NGO partner in this grant is Action Housing, an affordable housing agency that has pioneered passive house quality, construction, super insulated and super tight in Western Pennsylvania. They also focus on rebuilding walkable, workable communities. The graduate students benefiting from our grant are mostly international students. Many come from countries where rapid population growth means that buildings don't get renovated, they get torn down to build something larger. Many, too, are new to the idea that they, as students, can influence municipal redevelopment. The buildings that Action Housing bought in the fall as the focus of our work are shown here. D'Imperio's was Hazelwood's last grocery store. It was family run for 80 years and closed in 2009. The buildings on the left and the right were a bakery and a beauty salon with housing above. We launched the grant last fall with a course in sustainable materials and renovation. Some students saw wood frame construction for the first time. They learned about the challenge of old foundations in a wet climate. And we also frequently had to readjust our ideas to fit the project budget. Students researched and developed details for new assemblies, layer by layer, and created a layout for a rooftop vegetable garden for the grocery. At the outset, Pittsburgh's food bank was the intended tenant here, and they were interested in showcasing rooftop gardens. We also used infrared thermography last winter to look at Action Housing's recent renovations. In both sets of pictures, the home on the right is an Action renovation. The bluer surfaces are colder, which show how little heat is leaking from the inside compared to the building on the left that's not renovated. We also are learning a lot about the business challenges of supplying fresh food in neighborhood small markets. The picture shows the project team, the food bank, and a grocery consultant, and we were meeting in an old church that Action Housing renovated for a community center and a new branch of the Carnegie Library. The structural analysis for the grocery roof showed that it would not support a full vegetable garden, even though the roof gets full sun. So the students explored sub-irrigated planters. These are a flexible way to save water and do urban gardening. We added a third building to our project, a 3.5-story masonry building 2 blocks from the grocery store. Action is trying to fill this building with community service organizations that provide jobs. The students also got to explore the neighborhood a little more this summer, and on the left you see the sequence of the church to library renovation. On the top right, you see a still active church that provides free clothing in the community, and this is deli owner Mike, who provides free treats to students who get A's. We created renovation strategy sheets for the walls, foundations, and roofs. The students also, and they also did modeling to ensure that there was no potential for condensation in those assemblies. And they identified better product choices, one of which is a spray foam with a global warming potential of only 1. The students did energy modeling for the SPAR building and for the grocery. Sorry, just a minute. They were able to convince the project team to insulate the basement, not only for thermal but moisture control. Renovation in the grocery store should begin in November. The CMU team was successful in identifying better insulation products, better HVAC equipment, and adding light tubes to the project. The project team also accepted our recommendation to use the latest energy code rather than the one that Pittsburgh currently adopts because it's better. We've proposed a completely new HVAC system for the SPAR building. We don't know that it will be chosen, but it's an HVAC water loop with ERVs for ventilation air, and it should provide much better performance, but it's difficult to model. We also recently attended a meeting of the Hazelwood Initiative and heard from people who live and or work in the neighborhood and are trying to shape its future, like Diane Shank, who owns a produce stand. The Hazelwood Initiative recently bought and renovated a school that was closed in 2006 and reopened this fall, and they're justifiably proud that Hazelwood's major renovations are a library and a school. The second year of the grant supports student work in the community to develop 3 workshops about sustainable renovation that residents can do. We'll hold these workshops in the spring and summer after a class this spring. And the last of the workshops will feature CMU's digital fabrication trailer. The DigiFab trailer is a mobile digital fabrication tool shop that was designed and built by undergraduate architecture students in CMU's Urban Design Build Studio. By taking digital fabrication technology to the community, we hope to interest young residents in careers in design and construction. As in the Stone Soup tale, the students, citizens, and professionals involved in these projects are creating a richer blend than any one group alone could achieve. We're excited about the constructions and the workshops in year 2 and are keenly aware of the extended value of the education that the Pillars Grant supports. Please visit our website and contact us to add to the soup. Thank you.
Thank you, Nina. That was a wonderful example of collaboration within the community, and what a great result, and we'll look forward to year 2. And Nina also brought a student of hers here, so if you want to say hello or ask questions later on, please do. Well, you can wave, and we won't take questions now. You can just wave, and they can ask you later. So next we have Uta. She specializes in scientific work on building construction, interior and facade design, dealing with research in the field of creative problem solving and product innovation. Since 2005, she is one of the organizers of the yearly conference Facades 200X. And in 2009, she co-founded the European Facade Network. She is going to be sharing a little bit about how the partnership between Delft University of Technology and OWL are partnering to facilitate a mobile laboratory that will provide partnering universities of the European Facade Network with a platform to share knowledge and demonstration projects. So, welcome, Uta.
Thank you for introducing. As to begin, you already mentioned that this is a joint project with the Delft University, and we are heading with our topics towards the facades in general, since we think that this is one of the most important elements in the building skin to achieve advantages or to achieve development in energy efficiency and in also better spaces. Just a few words to our school, since in Germany, and it's a small university, but we are the largest faculty of interior architecture in Germany. And this is why I allow myself to cite Walter Gropius from the Bauhaus. And we are focusing on human-centered design, which was already mentioned by the Purdue University, which means also to improve the interior, the acoustics, the sound. And another aspect is that we are very much internationally connected, and that we think, as it was also mentioned already now in the presentation before, that a lot of our doing and a lot of our education is relevant for global issues, and that means also these are all international students coming from all over the world to study our international facade design master course. And our European Facade Network is based on 4 countries: UK, Spain, Switzerland, Germany, and Delft University. As another achievement, which is very closely linked to the activity that we are doing here with our workshop, is an activity in India where we really hope to introduce more of these innovative design methods and collaborative achievement with other Indian universities, so to extend these ideas of workshop and facade design. And this is the next event, starting actually on the 21st of October in Germany. It's the Glass Tech. It's the largest fair on glass, on glass products and glass fabrication. And this is our stand, our booth, based on the Architecture for Humanity and Alcoa grant. So we are presenting the results, the mock-ups, that we built with our students on this fair to an international audience, and also do a facade consultancy for architecture students with our facade master students. So you can see the mock-ups lined up here. And the facade consultancy takes place during 4 days. So we expect students from other German universities, and we expect also other visitors that come and see the mock-ups during the fair. the next event coming up is a conference in Lucerne, which is one of our European Facade Network partners, and this is dedicated to the adaptive facade envelopes. I'm just coming back to that, since this will be a new project. Also during the conference, the students will build new mock-ups based on the idea of adaptivity with electronic solutions. And just this is a very interesting thing. We just got a grant from the European Union as a core group of the European Facade Network on adaptive facade networks, which means that we will have two representatives of each European state being involved in the topic of innovations in the building skin. And just to come back, what are the topics that we have to innovate? So one thing is about the acoustics. Actually, it's a very big topic in our research based on interior design and on working spaces. But actually, as you can see, we also try to combine the visualization of sound, because sound, we heard it, and everything on perception is very subjective. So this means also that you may perceive sounds differently when they are in coordination or with other visualized things. So what we do also is we create new, based on the interior design, and I'm coming back of like how this is related to the facade design. Of course, the facade is one part of the interior room, and I think presently there were not enough attention paid to the aspect that how the facades are influencing the interior as well. So this is a test scenario, so we're doing real tests, mostly with our students and later on with external partners in offices in the real world, in praxis, and where we are testing how sound and acoustics and visual distraction are in correlation to each other. Another aspect next to the human environment is the whole topic of 3D shaped design, and linked to that to new design methods. This is an example of how the new production of Zaha Hadid's building in Korea was done on a very high-tech level. And I'm mentioning this because before, a lot of these works were done under real bad, working condition, actually mostly in China or in other countries where we have still cheap labor. Another aspect, of course, are new construction methods. We heard about 3D printing yesterday from Michael already for the mock-ups. So this is an aspect where we can really find other solutions for construction and for mounting things. Another thing is thinking skins. This is really related to adaptivity. So in how far do we new IT technology, how we need it to find out to make our facades more reactive, so more adaptive to what we need. And this is all about technology and design. How much can we balance it? Architecture is not just supposed to be design, but we have to find new products that are very much focusing to new design methods as they are usual in industrial design. And finally, it's about the collaboration of architects and engineers. So this is what we really try to train the students, which are architects or engineers in our courses, in our international courses. And so it's all about cooperation and about learning and understanding each other if we really want to work interdisciplinary. So this means the experience that Linda, as a second part of our project, will explain afterwards, the very personal experience of that you can deal with other, let's say, disciplines and with other nations, and can make out of that, through experimental design and construction, you can create innovation. Actually, this is what we want. In terms or to move forward with the challenges related to climate change and energy efficiency, but also to a better, let's say, environment for the users, not only in the industrial nations, because this is something that is important for everybody in the world. So thank you very much.
Thank you, Uta. It was wonderful. So we're actually going to have a second part to this project. And so Linda Hildebrand, she's part of Delft's Facade Research Group and is involved in several publications like the Image Book Series and a few other different research projects. She is also just finished her PhD in analyzing the relevance of embodied energy for the building sector, and was just appointed professor of recyclable construction at the RWTH Aachen this same year. So welcome.
Thank you. Thank you. Yes, hello, thanks for having me. I'm Linda Hildebrand. I'm really glad to be here, and I'm going to give you a practical insight of what Uta just explained. It's about this working together in the universities, and I'm going to explain how that worked with the workshops. So we did that with TU Delft. I worked in Detmold and in TU Delft. And today I'm representing my boss, Uli Knack. He was not able to come, and he asked me if I would do it, so this is my job here. You see the map with all the different locations. Detmold is based here in Germany, and I'm going to tell you something about the workshop we did in Bath. That was a workshop with facade engineers or facade engineer students and environmental design students in Bath. And the idea was to build facade mock-ups that have low cost and a lower cost than a regular facade on site has. So we started with ideas in Detmold. The facade engineers had to define some aspects. I traveled to Bath, worked there with the environmentalist students, and they had to define the concepts, and then in some weeks' time they had to talk, and via this distance, Bath, Detmold, they had to communicate and define the details of their construction. So they were interdisciplinary teams and also with different nations. Meanwhile, that was the student part. Meanwhile, we were preparing the workshop, so we had an actual building week. We transferred our office into a preparation, workshop. We had to manage not only to carry all the wonderful tools over there, we also had to find a way how we can deal without furniture, still have a workshop. So we became truckers. We loaded up a truck full of tools, and we drove the 17 hours from Detmold to Bath. And being on the only place I've ever seen where there are more men restrooms than women restrooms on a trucker fair. And then we were in Bath for 1 week, the Detmold students and the Bath students. And you might recognize the tent. That's the one that we will also show on the glass tag. That was our workshop. And the students prepared, and they erected the tent. And of course, you get an idea of the workshop. These are the rollers where we had the tools, and we could also lock them and move them. And that were the first days where we tried all the tools. We're really wonderful festival tools, and we are really glad that we have this high-level tools. Also, the students really appreciated that, working with these tools, and especially these guys, they had a really good feeling how to work with a chop saw. That was the most favorable tool there. It's a really powerful thing. And after they got a feeling, the actual work started. So we needed 2 days to set up everything, and then they had 3 days to work on their facades. And of course, not everything worked according to their plans. So at some point, they had to face technical problems, like the bamboo they ordered was bigger than expected. So they had to adjust the design, and as you see, it overlaps here. So we had to find a solution. This part is then on the very corner, so it can overlap. Things like that are real practical issues that you need to consider. And this changes the thinking and the perception of design. So the students were really were really focusing on it and redeveloped their design and attached it and adapted. And in the end, they were really, one slide is coming first. They were really dedicated to it. It was really raining, and at some point, our tent was completely wet. There was a grave going through the complete tent, and they were really making the best out of it and having fun, although it was quite challenging. And in the end, they were really happy with it. You can tell by their faces. They really enjoyed it. I think they learned a lot. And in the end, they were pretty proud. Also, having this experience, working with people they didn't know before, and also coming from different perspectives that gave a good impact. And we ended this week with the facade conference, and the students were presenting the mock-ups in the very front, and all the teachers came by and all the people visiting the conference, and we had a good discussion then on the mock-ups there. We tried to use these mock-ups further and to communicate what we were doing. So we created a format where all these facade mock-ups are communicated with. This is the local concept, the local course, and you see that this poster, this information concept is repeated again. This is the Thinking Skin, a workshop that my colleague did with the university in Aachen, and they used the same poster and they used the same criteria in order to communicate it. So when you see a poster, you always get the same information, although you have different topics, and this is the idea how we try to proceed this. It is a lot of hustle to do this workshop, but why is it worth it? Of course it's fun, although it's challenging. It connects not only the disciplines but also the nation, and I think it makes better engineers because this hands-on approach is really educating them. Okay, my last slide. Thank you. If you need more information, we have a couple of websites you can find more info on. Thank you.
Thank you, Linda. Thank you. So I guess we were probably all imagining our first time actually building something and all the little disasters you had to deal with. Yeah, that's what I was thinking about. So this is going to be the last presenter of this segment. And so we have Lara Barbosa. She has earned a PhD in architecture and design at the University of Sao Paulo in Brazil. She's also the author of the book Design Without Borders, Relationship Between Nomadism and Sustainability. She will be talking about the APIS project, which is a collaborative project of a mobile bathroom for collective use within temporary shelters after disaster. So welcome, Lara.
Okay, good afternoon. My name is Lara Barbosa. I am a PhD professor and also a coordinator of a research group called NOAA, Center for Habitat Without Borders, at Architecture and Urbanism Faculty of University of São Paulo. This project is developed in Brazil and it's supported by Architecture for Humanity as part of the Academic Partners in Building and Construction founded by Alcoa Foundation. I would like to thank Alcoa and Architecture for Humanity for this invitation and also for the opportunity to be part of this program. This picture shows I'm running. Okay, now. This picture shows the city of Dorado, which has 15,000 inhabitants and is affected by floods frequently, but this disaster doesn't destroy their houses, but makes unsheltered people while their houses are dirted with mud. When the river rises, people are sheltering in public buildings, which are improvised shelters, with not enough bathrooms during 7 to 14 days. You can see the shelters in yellow on the map. Since the beginning, we united the vulnerable population with the researchers, local authorities, and non-governmental organizations, and we are engaging the participants in order to promote resilience. We promote workshops to hear what they have to tell about their experience with floods. And that's when we decided to make a bathroom instead of any kind of project. In that region, people used to do food and crafts with banana. This resource is available in the region, so we want to encourage the people to development of new products. After learning about their culture, we did another workshop to develop new products using banana fibers. We experienced new components that they didn't know that was possible to do during the third workshop that we realized. In this city, there is a small factory that produces papers with banana fiber. So we started developing ways to produce a stronger material. We tested the use of natural glues and the application of bee wax. In this project, these panels and boards will be used as toilet partitions. Now we are studying the size of the cabins and trying to do different forms with this. You can see the first preliminary study, and now we are trying to change the form. And we will use here the banana fiber. It will be this component, combined with aluminum from Alcoa. We are planning to make a feasible prototype from a container, transport it on Brazilian highways, and set it up in El Dorado City. This mobile bathroom will be installed next to the existing temporary shelters, which are schools, community centers, and public buildings. We proposed a modular mobile bathroom, so we will prototype just one unit with capacity for 60 people. The emergency bathroom has showers, toilets, wash basins, and washer room areas. When we started to calculate the dimension of water and sewage tanks, we realized that it would be necessary to rethink the systems and propose the reuse of water. We also include a toilet accessible to people with special needs. So we redefined the source of water, which will be the water from the flood. Based on another experience that occurred in Brazil, the water will be treated in a station with membranes and directed for sinks and showers. Reuse will go to the vacuum toilets with reduced sewer. Here you can see the size of this treatment station that will be fit here. It's small. Based on the sustainable principles, it has solar panels to collect energy to heat the shower water. This system was also developed in Brazil with low-cost materials. We are studying changes in the cover frame to accommodate about 15 panels. This company is known as Linux Solar because the product is easy to make and they offer free access to the manuals. Through this initiative, we are promoting one of the steps of the Hyogo Framework for Action, that is, use knowledge, innovation, and education to build a culture of safety and resilience at all levels. I would like to quote Paulo Freire, who was an advocate of autonomy in educational practice. He's saying that learning is for us to build, rebuild, notice in order to change something that is not produced without openness to risk and adventure of the spirit. This work has been going since 2010 in this town that has been regularly affected by floods. Now we are revising the preliminary project to start a prototype in the next year. I would like to appreciate again, to say that we appreciate the support of Architecture for Humanity and Alcoa, because without it, it would be very difficult to get sponsors and to be able to build a prototype. We hope that this project could inspire many architects in the world. You can follow us in different medias like Facebook, Twitter, Pillars of Sustainable Education, and also the website of the research group NOAA. Thank you.
Thank you, Lara. That was wonderful to see how a community is really taking on their own response. So before everyone sneaks out of here, I just want to say we're going to get well, just to close off, you can follow the Pillars of Sustainable Education program on their website, which is pillarsofsustainableeducation.org, O-R-G. You can also find it on Architecture for Humanity's website. I'd encourage you to, meet all of the speakers, ask them a lot of questions, take advantage that they're here all in one place, coming from all corners of the world. We're going to start our second segment at 1 o'clock, correct? And we're going to be focusing on community engagement. So we're going to have designers talking about projects from Hungary, New York, Peru, and much more. And we're going to have a little bit of competition, but I do have to encourage you to visit. Our colleagues from Architecture for Humanity are actually going to be at the Marimekko discussion area talking about sports for social change. Our Football for Hope program is a 6-year program that we've run that we just completed, completing 19 centers throughout Africa. So I encourage you to also attend that. That's at 1:30, but then hurry back here for more. So thank you, everyone, and see you at 1 o'clock.